Hello everybody and welcome to another tutorial on C programming, and the objective of this tutorial is to familiarize all of you with the techniques of searching in an array in C. So there are basically two techniques of searching in C or in any other programming language for that matter. The first of these techniques is linear search and the second one is binary search. So in this tutorial we'll be concentrating on linear search, and in the second video tutorial I'll be apprising you about the binary search technique. So what do we understand by the concept of searching in an integer array or any other array? So let us assume we have an array that consists of 7 to 8 numbers, and we want to see whether a particular number exists in that array or not. So the only way to do that, the basic and the most elementary way of doing that, is to compare the number that we want to search with all the numbers in the array one by one. So let us say there are 5 numbers in the array, and I want to locate the number 6, whether the number 6 exists in the array or not, and if it does exist, at what position. So to check whether the number exists in the array or not, what I need to do is I'll have to take the number that is 6 and I'll have to compare them with each and every number that exists in the array. So if I find a match between the number that I want to search and the number that exists in the array, the numbers that exist, then I can say that our search is successful and the number that we want to locate is present in the array. So I'll be showing you a diagram of linear search, a diagrammatic representation. So this is here an article on linear search obtained from Geeks for Geeks. So I'll be referring to this article in order to explain the concept of linear search. So you can see it says that problem: given an array ARR of n elements, write a function to search a given element in X in ARR. So ARR is a 1D array and its size is n, that is, it can hold n elements at a time, and we have been entrusted with the responsibility to locate for this number X. So let us take a look at this ARR array first of all. So this ARR array, you can see that it contains some numbers, and the size of the array is has been represented by n. Alright, and the number that we want to search is X, which is the value of which is 110. So if we want to check whether the number 110 exists in this array or not, what we need to do is we'll have to compare 110 with each and every number in this array. So first of all, I'll compare X with 10, but there will be no match because 110 and 10 are entirely different numbers. And then I'll be comparing 110 with 20, then with 80, then with 30, then with 60, and so on, until and unless I come to 110. So here at this position I'll be able to find 110, and it will match with the value of X. So then it will output 6, that it is present, element X is present at the index 6. So we know that the index of arrays start from 0. So if we start counting from 0, we can say that 0, 1, 2, 3, 4, 5, 6. The number 110 that we wish to search is present at the index 6 of the array. So let us take a look at the second example that we have here. We have another array, and this time we have to search for the number called 175. So if we take a glance at this array, we can say at the very beginning that 175 will not be found because it doesn't exist in the array. So like in the previous demonstration, it will compare the value of X with all the numbers one by one in the array, and after it doesn't find a match, after comparing all the numbers in the array, it will not be able to find any matches whatsoever, and so the value of this at index will be -1, which represents that the number could not be found. So this is how we carry out linear searching in C. And the drawback of linear search is that if we wish to search for a number in an array that is really big, say it contains 100, 200 or even more numbers, then we'll have to cover the entire array and compare all the numbers in the array one by one with the number that we wish to search, and in that case it will take a very long time and it will be very inefficient. So this is one of the drawbacks of this linear search problem, and The longer the size of the array, the greater time it will take to search through the entire array, because it will compare all the elements one by one. And the complexity of linear search algorithm is ON. Okay, so ON, it means that is the size of the time that will take to search through the array will depend on the size of the array. So if the size of the array is n, the time it will take to search through the entire array will be n. So it essentially means that this technique is not very efficient, because it will take a lot of time if we are focusing on an array which is very big and contains lots of numbers. So let us now take a look at the programming code for linear search. So I have this program right here. So first of all, you can see that we have taken an array that can hold 100 elements. Obviously we will not be taking 100 elements, we will take a fewer number of elements. And so first of all, okay, let us take a look at the variables first. First of all, there is the array itself having 100, capacity 100, then the number that we wish to search in the array represented by the variable search, then C and N. So the total number of elements that we want to include in the array at a time, that is represented by n. So first of all, we are taking the value of n as the input, and after we are taking the value of n as the input, we are executing the for loop, and this C is actually the loop counter variable, and it goes from 0 to n. So the number of elements that we wish to include in the array at any given time is given by n, and after that, using scanf, we are accepting values in the array, and later on we are accepting the number that we wish to search in this array, and it is stored in this variable called search. Okay, so like in this example, the number that we wish to search, we wanted to search in the first example was 110. So just assume that we'll be entering a number that we wish to search over here, and this value will be stored in this example it was stored in x, and in our program it will be stored in a variable called search. Okay, so it will traverse, after this it will execute the for loop once again from 0 to n, and it will traverse to the entire array, and it will compare all the elements of the array one by one with the variable stored in search. Alright, so it will just traverse to the entire array and compare all the elements one by one with search, and if it finds a match, what it will do is it will just print the location at which the match was found, and then it will break out of the for loop. So in this case, if the match is found at this position, that is 110 is found at index 6, it will simply output a message that the number 110 that we wanted to search was found at the position 6, and after that there is no point in continuing the search any further, because the number that we wanted to find has already been located. So we'll break out of the array using a break out of the for loop using a break statement. And later on, after getting out of the for loop, what we'll do is we'll check the value of C and we'll compare it to n. So n represents the total size of the array. So if after traversing to the entire length of the array, the value of C becomes equivalent to n, we can conclude that the number was not found. Alright, because if the number was found, it will not have a chance to go as far as n. So if the number that we wish to find in the array, if it was located at some point in the array, it will the value of C will not increase up to n. Okay, so the value of C will have a lower value than n, and it will break out of the for loop as soon as the number is found. But if after getting out of the array, if we see that the value of C is equal to that of n, it means that the for loop has executed in its entirety. Okay, so the for loop has started from 0 and it has executed all the way up to n, and this can only happen if the number was not found. So if the number was not found, the value of C, that is the loop counter variable, will be equivalent to that of n, that is the size of the array. So if that does happen, we can say that the number that we wanted to look for, it could not be found. Okay, and there is another way to solve this. What we can do is we can use a flag variable, but we are not using it in this program. So the easier way is to check for the size of C. So every time we traverse through the array, in each iteration the value of C is incremented. So if the value of C is found between 0 and n minus 1, what will happen is the moment the number is found at any particular position between 0 and n minus 1, it will print the index and then it will break out of the for loop. So the value of n will only the value of c will only be equivalent to that of n. It will only increment to n uh, only when it is getting an opportunity to go through the entire for loop. But if it finds after proceeding about halfway through the entire array, if the for loop terminates at any point, so the value of c will be at an intermediate position between 0 and n. It will not be equivalent to n under any circumstance. So we can say that uh, the number has been found at this position. But if the value of c is found to be equal to that of n, then we can say that the number was not found. So this is how we practice linear search. So let me run the program and show you how it works. So for the sake of saving time, I'll be just taking 5 numbers. So remember that the capacity of the array is actually 100, but it is not possible to store 100 numbers, so I'll be taking 5 numbers in random order. So I want to search for 88. So 88 has been found at location 2. So the location 2 actually is the third position in this array. Alright. So let me run the program once again and show you what happens when we search for a number that doesn't exist. So 1, 8, 22, 12, 45. So let us say we want to search for 74. So it says that 74 is not found in the array. So this tutorial concludes now, and I hope you've understood the process of linear search. Remember that this process of linear search is not regarded as a very efficient technique, because although it is simple to understand, it is simpler than binary search. It is considered to be inefficient because the time complexity of this technique is O(n), which means that the larger the size of the array, the longer it takes to search through the entire array. And so this can pose a lot of problems if we are to search through an array that is having a huge capacity. So if for example this array 100 was packed with 100 numbers and we had to search through the entire array of 100 numbers for any particular number, it would have ended up taking a lot of time. So this technique is therefore considered inefficient. So in the next tutorial we'll be learning about binary search, which improves upon the shortcomings of linear search and is considered to be a lot more efficient than binary linear search. So this concludes this tutorial, and if you have any further doubts, please you can discuss them in the comment section of this video. Thank you and have a nice day everybody. Take care guys.